Hello, this is Dr. Harrington, and we are now on lecture 17, page 11, on marginal analysis. So we define marginal cost. So anytime you see the word marginal, that's going to be the rate at which cost is changing with respect to x. So we will use the marginal cost at a given production level x to approximate. So that's the key word. This is not the exact value, but this is a good approximation for the x plus 1th item, so for the next item. So for example, suppose I have c of x is equal to 1000 plus 25x minus 0.1 x squared be the cost function for a product. Well, let's go ahead and figure out what it costs to produce the 100th item. So the cost function, what we're going to have is, we're going to have c of 100, and we just simply put that back inside the function, right? So that's going to equal to 1000, and then plus 25 times 100, and then we're going to subtract off 0.1 times 100 squared. Now if you just type that into your, well, I mean, you can just look at this. Actually, this isn't too bad really, because you get 2,500 minus 1,000, so you can actually do that in your head. So 1,000 plus 2,500 minus 1,000, that's just equal to 2,500. So we're going to have 2,500 as our answer. Okay, now remember what our units are going to be. Of course, that's dollars amount. Now we want to find the rate at which the cost is changing with respect to x with the production level of 100. So let's just go ahead and take the derivative, d of c. So d of c with respect to x is going to be equal to, that's just the derivative of c. Okay, it's not too bad. So go back to our original function. The derivative of 1000, that's 0. Right? The derivative of 25x is 25. Minus, and then of course this little 2 can come on down to the front, and write that as 0.2 times x. So this whole thing just works out to be 25 minus 0.2 times x. Okay, so the cost, so the derivative at 100 is equal to 25 minus 0.2 times 100, which is equal to 5. Now I want you to note this is an approximation. For the cost of the 101st item. So what we see is that cost is actually increasing by $5 per unit. Okay. Now if we were to actually figure out what is the actual cost, so again this is the actual cost, and for notational purposes we typically use delta C for the actual change. So we're going to have the actual cost is going to be C of 101 minus C of 100, which is equal to, and again I did this calculations for you, that's $2,504.90 minus 2,500, which is equal to $4.90. Okay, now this is the actual change. Now you can see that the approximation $5 is pretty good. $4.90 is the actual change. And a lot of times in business, you don't really care about the cents or the pennies. You really just want the big picture. So in this case, we always just use the derivative and we don't use the actual amount. Something else to note here is that you need a calculator to actually figure out most actual, like to the penny amounts of change. Whereas you don't need a calculator or any fancy equipment to figure out an approximation. Now let's figure out what this means geometrically. So here's what I have for the actual function. Whoops. And I actually have it all graphed out for you automatically. Now let's see. Okay. At this point here I have x. So at this point here, this is going to be c of x. So that's my c of x amount. And at this point here, this is my c of x amount, x plus 1. This is the next amount. So that's my c of x plus 1. Okay. Now you can actually see this is the real difference. This is the real actual change between from here to here. All right, this is what you get. So you get this little amount here. This change here is going to be your delta c. That's this distance, which is going to be c of x plus 1 minus c of x. And again, that is what you need a calculator for. However, if you look at the line, this tangent line is easier to calculate. So this is the tangent line. And here we're going to have the slope is just the change in the bras over run. So it's just bras over run. Which in this case is going to be the derivative with 1 unit of change. Now, if I put in x plus 1 in this guy here, you'll notice sometimes it's over, sometimes it could be under, depending on what the graphs look like and how they behave. In this case, the tangent line is going to give an over approximation, an over estimate. But from this point to this point, from this line here to up there, that's going to be our derivative, c prime of x. Because again, this distance here is 1. The change in x is just 1, which is what we have there. This, to find actual change, the point is that the actual change is hard to do. A lot of times you need calculators or something to do there to actually figure out the actual amount. Whereas the tangent line approximation is insanely easy. You can just take the derivative and plug in the number, and a lot of times that's actually a whole lot easier. Cool. So let me just make a note of that down here. So c prime of x approximates the delta c. In other words, the rise along the curve. Cool. Thanks.